Good afternoon, everyone. Welcome to today's webinar on Beyond IoT Unlocking the New Possibilities with AI at the Edge. I am Govardhini and I work as an IoT developer at DigiToad Technologies. And in this session, we will understand how IoT and AI can work together to create smarter real time systems. But before we dive into the technology, let me introduce who we are as a company. Okay. Digital Technologies, we provide the solutions in testing measurements and industrial automation, 5G or 6G wireless and AI-driven IoT. So we work in distribution, system integration, training, and e-learning as well, where we help industries, academia, and researchers stay ahead in the technology. Now that you know about us, let's see how we engage with academia and build future-ready skills. So we support universities and students with virtual labs, certification programs, industry readiness training, and structured e-learning also. And in this, students will gain hands-on skills on HAI, IoT, robotic, and FPGA, where we will be preparing them for jobs and research. So since I'll be guiding this session, let me also share a bit about myself and my background as well. So I have 2.5 years of experience as a IoT developer, specializing in IoT monitoring systems, sensor connectivity, and cloud integration. So I have worked with platforms like AWS IoT, Adafruit IO, ThinkSpeak, and Blink cloud platforms, and supported academia labs and training sessions also. So with this background, let me now walk you through what today's session we will cover. Okay. So, in this webinar, we will be covering the difference between AI and the IoT when they are used separately, and why we are going to combine them, and why they call AIoT as a powerful technology. And we will also walk you through the workflow of AIoT application, as well as we will show you the live demo application also, live working of how AIoT platform works. And so, to begin with, let's understand why in today's world data is all around us but often underutilized. So, devices generate a flood of data, right? Okay, let's resume it here. Devices generate a flood of data, right? But unless we process and act on it, it remains unused. So, to understand the importance of combining the artificial intelligence and Internet of Things, let's first look at how they function separately, like the brain and the body. Okay, so artificial intelligence works like the brain, like it learns the patterns and predicts the outcomes. For example, in a movie recommendation system, is what you might like based on your viewing history, right? So it will learn and it will be giving you the suggestions based on the history of data. But artificial intelligence alone needs inputs from the physical world to be meaningful. That's where IoT comes in, connecting the physical world through devices. Okay, so IoT act like a body connecting devices and sharing data with the cloud. So for example, smart home devices like lights and cameras send information for real-time monitoring. But what happens if AI and IoT don't work together? What are the real challenges they have faced? Let's see them. Okay, so when separated, AI and IoT face challenges like IoT provides a raw data, but it's overwhelming without AI. AI lacks real time data from IoT, right? So both will be facing the difficulties, not like only one single technology will be facing a difficulty without another one. Okay, so and other things are decisions are delayed, automation is limited, and opportunities are wasted. So this shows us why AI is the missing piece in the IoT. So IoT generates data, but AI makes sense of it by adding the intelligence. So together they create a device that learn, adapt, and act instantly. Now let's see how AI and IoT already work together in our daily lives. Okay, so these are some applications, that is smart healthcare monitoring, smart homes and energy management, predictive maintenance industry. So AIoT closes the loop of sensing, thinking, and acting. This happens in real world scenarios just like these examples. So to build these systems, we need the right hardware and software. So let's see what to look for. when you are building this AIoT. Okay. So to build the AIoT, you need like you will be having the edge device, right? So which will be helping you to collect the data and connectivity where you want to, if you want to share the data to another system, or if you want to monitor through the cloud platform, you will be needing a connectivity where you will be connecting your edge devices to the network, and later you will be sharing those data to the cloud. Okay. And if you are going to build an AI model in the cloud platform, the cloud processing will be happening. So for that, you will be needing the cloud processing platform. And for at the end of the time, user will be wanting to monitor their machine health condition, or doctor wants to maintain the monitor the patient's health condition. They will be using some dashboard, like if they have any issues, they need to have an alert messages. So for that, they will be using this dashboard. Okay. So to build real world AIoT application, what do you need next? So talking about the hardware, which must support AI models locally and be energy efficient, and which offers and flexible connectivity also, right? So connectivity will help you to transfer the data, and edge AI model processing will help you for the faster outcome, and you will be getting the outcome at the faster rate, and you can share the data when you have inbuilt connectivity with your edge device. It will help you to share the device to the cloud platform at the faster rate. So similarly, in the software terms, it must enable programming and model deployment and the monitoring process also, right? Like how your edge device is giving the outcome, you need to monitor that also, right? So your software must have that capability. Now let's see an example of the ecosystems that support these requirements. Okay, so this is an AIoT board from ST Microelectronics. They provide and development boards and microcontrollers designed for Internet of Things as well as artificial intelligence. Okay, so they allow real-time sensing, local inference, and smooth connectivity. This makes them ideal for education, research, and industries. So I will just play the video, which will be showing you the give you the overview about the specifications of it. So that is all about our AIoT board. Okay, these are the specifications are of our board, which has a capability of AI processing at the edge itself, the microcontroller which we saw in this board, right? So it has the edge AI processing capabilities, and it also have the inbuilt three connectivities which will allow us to integrate the IoT technology with the AI. So this microcontroller will help us to deploy the AI models, whereas this Wi-Fi and Bluetooth modules will help us for the connectivity part. Okay, so once you have your edge device process the AI outcome, AI result, we will be using this connectivity like Wi-Fi module or Bluetooth module. When we are using the Wi-Fi, we will initialize it and we will be connecting it to the network. Later, once your board is connected to the network, it is ready to talk with other devices or ready to share the data with other platforms. So this is the capability of the hardware you will be requiring when you are building and complete AIoT system. Okay. Let's proceed with the ecosystems. So in ST ecosystems, you can see the different software tools like STM32 Cube IDE. So if you are going to program your microcontroller, this Cube IDE is the perfect platform for it. Why? Because it already have an IOC configuration file where it will be having an pinout configuration. You just need to generate the code for that. You need to physically initialize the pinouts in the IOC file. When you click on the generate code, it will be generating the code for the initialized pinouts. You don't need to type a code separately for initializing the input or output pins. Okay, and this software will also help you for deploying the code into your microcontroller. And this software comes with an command shell console where you can see the output of your deployed code. Okay, and next we are talking about Nano Edge AI Studio. This is an AI automated tool. Okay, so the students without prior knowledge on AI ML, or if they are from circuit branches or mechanical branches, they can use this Nano Edge AI tool. Why? Because they have an pre-built libraries, that is machine learning algorithms, where you just need to collect the data and you can train the model without any coding. Okay, you will just collect the data. Later you will go for training the model, and later you do the validation step and deployment part. During the demo session, I will be showing you how these tools will be working. And another programmer software tool we have here is STM32 Q Programmer, where if you have any bin files you want to deploy it into your system, you can go proceed with the STM32 Q program. And another tool we have here is IoT Craft. So if you are not good at coding and you want to do you are good at hardware tools, right? But you don't know what to deploy in your tool. So this STIoT Craft, they will give you an pre-built entire project. So prototype of your machine monitoring system for a specified hardware. So you just need to select the hardware tool and it will give you the project list of that hardware tools. You can just download the project and you can deploy it into your microcontroller. And next we have here is STHEI Developer Tool. Similar to Nano EJ Studio, if you want to train the model and build a new machine learning algorithms, you can proceed with this STHEI Developer Code. And another tool we have here is STM32 Cube IDE. This is for a like programming department like CS or IES. So if they want to build their model from scratch using the Python, right? But our microcontroller, it will be understanding only the C or C++ language. So if they want to build the model using the Python and later they want to convert it into C or C++, we will be using this STM32 Cube.ai, which will convert the Python model into the C or C++. Later, you can integrate it with the Cube IDE in the project, and later you can go for deployment. So even there are even more platforms in the ST ecosystem which can be used for different purposes. Like we have for vision development also, robotics also. You can choose whichever ecosystem suitable for your hardware tools. Okay. So talking about our application workflow in our AIoT system, right? Firstly, what we will be doing, firstly, we will be collecting the data, right? Firstly, we will be preparing the data sets using the different classes if you are going to collect, and you will collect the data. Later, what you will do, using those data set, we will be developing the models. Once the model development is done, later we will be deploying it inside our IoT board. Okay, so this will be the workflow for our demo as well. Okay, so once you have deployed the code inside the microcontroller, it will be giving you the real-time output. Once it is done, once it is predicting the output correctly, later what we will be doing is we will be initializing the connectivity in our board Wi-Fi module, and later we will be connecting it with the cloud platform like Adafruit, and we will be entering the real-time data, and as well as we will create a visualizing dashboard. We will set the triggers where we will be seeing the highlighted in red when it is not working properly, like machine monitoring system. Okay, so talking about our demo, so this demo will be developed using the AIoT Developer Kit. Okay, so this demo showcases integration of Edge AI and IoT to detect anomalies in the real time. So this IoT node is used to run the anomaly detection model locally at the edge itself. Later, we will be connecting the Wi-Fi module to the network, and we will be sharing the data to the cloud platform for real-time monitoring. So what is the outcome of these demos are you will be detecting the abnormal orientation changes in the real time live data, and later cloud-based data logging also we will be doing, as well as visualization and demonstration of AI at the edge combined with IoT for a real-time monitoring solutions. Okay, so talking about our demo setup, here I will be showing you in the camera also, live setup also. But before that, let me show you the real representation of that. So here we have the AIoT board, okay, that is from ST Microelectronics, and we will be interfacing the MPU 6050 sensor, which will be used to collect the vibration patterns from the fan, which is running at the 3 different speeds. Okay, so I'll be showing you the live setup as well. Okay, so now let me show you the live demo setup. So here we have the microcontroller, that is an AIoT board, okay, which is from ST Microelectronics. We have interfaced it with the MPU 6050 sensor, and we have connected like sticked it on the fan, which is running in the 3 different speeds. Okay, so this is all about the demo setup. Now let me show you how the projects will be built for the like complete AIoT workflow. Okay, so first step, as I said, it will be the data logger part. Data logger is nothing but what we will be doing is it will help you to collect the real time data from the fan. Okay, so let me just deploy the code. So this is the STM32 Cube IDE, which where you can program the microcontroller using the C or C++ languages. Okay, so it is an Eclipse based IDE, and here we have built an data logger code where we will be collecting the 265 buffer size data from the MPU 6050 sensor, and we will be transferring it to the microcontroller. Once your microcontroller is receiving like running the MPU data's vibration data, we will be building the model using that data set. Okay, so I'll just deploy the project here. Okay, so here you can see we are collecting the MPU 6050 data, that is real-time vibration data. Okay, and once you have deployed the data logger code here, we will just disconnect it first. Okay, next we will go for Nano AGI, where we will be building the models. Okay, so this is the Nano GI Studio, which is an AI automated tool. It will be having a pre-built machine learning algorithms where you just need to collect the data sets and build the models by training and testing. Okay, so this platform, it is not only used for building the machine learning models, it can be also used to collect the data sets also. If you want to collect the data sets from your real-time microcontroller edge devices, you can use these platforms for different projects. Okay, okay, so I just will start with the procedures. So here we will be having a different models. So when you click on this new project, we have 4 different models which can be built using this Nano GI Studio. That is, first one is anomaly detection. So anomaly detection is the model which we will be building for this demo application. So this will help you to find the abnormal vibration patterns or abnormal patterns from the normal data. Okay, so if you have 2 different signals which will be in differentiated with the type of it, like one is normal and another one is the abnormal one, we will be proceeding with this model. Next is n class classification model. That is like if you have a different varieties of classes and you want to detect it, here you will be using this classify model, where you will be collecting the data for different signals and it will be giving you the output based on that. Next is we have the detecting outliers in your system signal. It is like similar to n class classification, but here we will be using for single signal. Okay. And next is extrapolation for future prediction. So here I have built the model already. I'll just show you the how each step works. Okay. So for anomaly detection, it works in 5 different steps. First step is project settings, where you need to give the name for your project, and here you need to select the edge device. Okay. Once you selected the edge device, memory footprint will automatically get generated. And here you need to select the sensor. Since for anomaly detection, we are going to calculate the vibration of the fan, we will be using the accelerometer set. Okay, and we will be collecting the data in 3 axes. So you need to select the axis and sensor as well. Once you have done this, you can click on save and you can go for next step, that is signal. So here you will be collecting types of signals. One is regular signal and another one is abnormal signals. So in regular signals, you will be collecting the data without any interpretation in your model, and in abnormal signal you will be collecting the data with by providing the external disturbance to train your model. Okay, so here I have already collected 500 lines of data, but for demo purpose I'll show you how to collect the data for at least 20 lines. Okay, so when you click on add signal, you will be having a two different option to import the signal. That is, you will be having an import a signal from the file, right? If you have your own data set, you can just drag and drop it here. Or if you want to collect the real-time data, you can go for log signal from the serial USB. And here you need to select the correct comport to which your board have been connected. Okay, so once you select the comport, select the appropriate baud rate. And here for demo purpose, I'll just collect 20 lines of data and I'll click on start. So you can see here the data has been collected. So once this data have been collected, what we will do is we will just import this data to our project. Okay, so when you click on this next, you can just leave the delimiter as space. Like by default, delimiter is nothing but the space between your each data or each values. Each values will be separated by this delimiters. Okay, you can select whichever type you want and you can just click on import. Okay, so I'll just delete it. If you want to delete, you can delete, or if you want to download. As I said, this tool, it is not only for building the machine learning algorithms. If you want to collect any data sets in real time, you can just import the data set like by clicking on this download option, and you can save it in your PC. Okay. So once it is done, we will train with the abnormal signal. So here also we will do the same procedure, but by giving the external disturbance. Okay, so here when I give the login, and I'll just so so here you can see I have blocked the airflow from the fan. Okay, there is an difference between the vibration patterns in abnormal signals and normal signals, right? So like this, by giving the external disturbance, we will be collecting the normal sorry abnormal data. So once you have collected the abnormal signals, next we will proceed with the same procedure. When you click on next, you can just click on this import, so your data set will get imported here. Okay, so once everything like data set is done, next you need to check what is the accuracy of your model and whether you have collected the correct data set or not, right? So here that process is called as benchmarking in this Nano AI Studio. So in this benchmarking, it will give you the balanced accuracy and what is the RAM and flash memory it have been consumed. So I'll just give it trial run here. Just click on new benchmark and I'll give start. Okay, so once you are given the start, your benchmarking procedure will start. So now it is validating the data sets which you have collected in the previous steps. Now it will start generating the libraries which is suitable for your model. Okay, so once you get the accuracy, balanced accuracy, you can see that is the accuracy of your model. So when it reaches to at least an 80% or 90%, you can just pause the benchmark and proceed with the model validation part. Okay, so it will be giving you the correct RAM and flash, and it will also generate you the confused matrix for your collected data, like how you have collected it, with whether you have corrected the data sets correctly, and if there is any appearance of the data sets in each other, that one we will check it here. Okay, so you can pause this benchmark, just delete it for now. Okay, so in next step is the validation. So in the machine learning building part, model building part, the main step is about testing, right? Before we go for deployment, we should test the model whether it is working correctly or not. So in this validation step, we have an serial emulator. So we will be having a different models which will be suitable for your current project, and it will also highlight the best suitable model for your project also, which might be utilizing the less RAM and flash memory, and it might give you a more accuracy also. So the highlighted one, if you click on this serial emulator, here you can just, in the previous step, it will be giving you an iteration cycle. Iteration cycle is nothing but a number of training cycle your model should go through. So you can just add on another 10 cycles, that is I'll give as 30. So the more you train the model, the more accurate your model will be. So I'll just click on the, I'll give 30 training cycles, and I will start training the model with the normal vibration pattern. I'll not give any disturbance here. So once it learns the normal vibration pattern, when we go for testing, other than these patterns, whatever signal it is generating, it will be detecting it as an abnormal vibration pattern. Okay. So now let's go for detection.
65 65.
Anup, can you mute yourself? Okay. So let's proceed with the detection part. Here we will be testing whether your model is working correctly or not. So here I'm not producing any disturbance. So it is showing the similarity score as 100, which means there is no disturbance in your model. But when I block the airflow here, okay, so it will change the vibration pattern. So here you can see the similarity score is being changed. Okay, so this is how we will be testing the model using the NanoGI Studio. Once you have tested whether your model is working correctly or not, next we will be proceeding with the deployment part. So in deployment, when you click on this and compile library, you will be getting an zipped folder to save it in your PC. Okay, so I have already saved it in my laptop, and I have integrated it into our project as well. So I'll be not downloading it again. I'll just open the Cube IDE. So the NanoGS Studio libraries, I have created a new folder for this in my project, and I have created two different folders where I have included .h files here in INC folder, and library files in the .a files in the library folders. Okay, so this is the IOC file which I was talking about. Let it get loaded. So yeah, here you can see we will be configuring the ADC pins, or if you want to configure the I2C pins in your projects, you will be selecting it here. Okay, in this pinout and configuration tab, you can go for system core, where you can configure the GPIO of pins or external interrupt pins or RCC, whichever suitable for your project. And in analog, you can go for ADC configuration also, it is there. You will be configuring it manually here. Once you have configured the pins which is required for your projects, later you can just click on this generate. So when you are clicking on the generate tool, you don't need to again program using the C or C++ for the pin node initialization. Okay, so it will be initialized in prior by using this IOC file. Okay, so talking about our main.c, here this is the main file where we will be writing the functionality which we will deploy it in the microcontroller. So here what we will do, we will be making it to undergo 20 training cycles. So your microcontroller will learn using the real-time data. Later it will be doing the prediction. Once it is done, next we will be proceeding with Wi-Fi module initialization. We have the Wi-Fi module inbuilt with the AIoT board, right? So what we will do, we will be initializing the Wi-Fi module in that, and we will be giving the network configuration so that it will get connected to that network. Once it is connected to the network, okay, your microcontroller will be ready to transfer the data from your microcontroller to the cloud. But how we will be transferring the data, you will be needing some communication protocols, right? So not just the network connectivity it will help you to transfer the data, but to talk with other platforms, you will be needing some communication protocol. So here we have used the MQTT protocol, and we have initialized the MQTT protocol, and using that MQTT we will be publishing the data from our microcontroller to the cloud platform. So this MQTT, it will be working on three different components. One will be the publisher, and another will be the subscriber. In between we will be having the server. So in publisher, what they will do is they will just publish the data, and subscriber just receive the data. In between we have the server. Why? Because publisher will not directly communicate with the server, subscriber. In between, we have the server which will help to communicate with each other. Publisher will share the data to server first, and later server will share the data to subscriber. If why this happens, because we will be having a two or more subscriber or two or more publisher also. Each will be having their own IDs, right? And subscriber, they will be having their unique topics also. So when they are subscribing for a specific topic, they should receive data from only that topic, not from any other topic. So server will take care of these things. So server will be configuring all the topics inside it. Okay, when the subscriber subscribe for specific topic, they will receive the data from those topics only. So there will be no mismodification in the data. Okay, so we will be using the MQTT protocol for transferring the data there. So I'll just deploy the code now, and I'll show you the output of my project. Okay, so here you can see first your Wi-Fi module will get initialized. Later it will get connected to the network, that is to our hotspot credentials. Okay, so once it gets connected to the network, let me turn on the hotspot first. Okay, I'll just reset my board. Okay, so I have turned on the hotspot from my mobile, and it will get connected to the network. So next procedure, MQTT will get initialized. You should initialize the communication protocol as well. Later it will undergo 20 training cycle, where it will be learning the data from real time. Okay, later it will be publishing the data. So here you can see without disturbance it is sharing the 100% similarity score, and it is detecting normal. And when there is a abnormality, it will be showing the anomaly detected. So this one we will be monitoring in the cloud platform, that is Adafruit. So here you can see, okay, I'll just refresh the page. Okay, so here without the without any disturbance, it is showing the 100%. So I'll just block the air, and again there will be a anomaly detected. So like this you can trigger the data also. Not only this, for real time systems you can also trigger an alert messages to your mobile phone. So when there is an abnormality detected, you can connect your server to the email notifications or SMS notifications, where you will be receiving whether your motor is working correctly or not. So that concludes the demo. Just on this slide. So we have seen the demo, like how our complete end-to-end AIoT system works, right? So now let's see, like, where can you find this end-to-end solution or support to build and deploy AI-powered IoT solutions? So we provide more than hardware. We deliver full AIoT support as well from DigiToad side. Okay, and we will also provide you an AIoT hardware and solution supply, and we will set up the lab programs at the colleges. Okay, and we will be giving you the once the training is done. Okay, we will be giving you an virtual lab access. We have a skills block platform. It is an online education platform offered by the DigiToad. Okay, so after the training, we will be uploading the virtual lab sessions in our skills block platform, where the students can access the virtual lab to do their projects in the real time. Okay, so another thing we will be providing is technical support. So if the student have any academic projects and if they need any internship supports, we will give that support also, and hands-on training and workshops. Once we have supplied the hardware as well as the training system, we will also give you an 5 days workshop where we will expose you to the hardware which you have bought, and we will make sure that you will be learning the technology from basic to the advanced level by step. Okay, so that brings us to the discussion part. I would love to hear your questions or experiences or challenges with IoT and AI which you have faced. So let's make this an interactive session. After that, I'll close with my final thanks. So, you guys have any questions regarding the webinar? You can just drop the queries in the Q&A box.
Attendees can unmute and talk. If you have any queries, you can talk, or else you can drop your questions into the Q&A box.
Okay, so on more virtual lab access, what exactly? So when you're buying the solution, like hardware platform from us, right? So once the training is done, like once you buy the platform, we will also we will send our application engineers. They will provide you an 5 days or 10 days workshop based on your requirement. We will expose you to the complete hardware as well as software solutions. Okay, we will expose you to how to use different hardware tools from the ST ecosystems, like how I showed in a demo application. You will be building it on your own. Okay, so we will make sure that at the end of the workshop, you will be ready to use your hardware integrated with the software. Once it is done, other students from your other batch, right, if you want to expose them to the same platform, we will be giving you a virtual lab access, where you will be sharing us the mail IDs for the registered students. Later we will be giving the access from the DigiToad side. Sure, ma'am. Like you can just drop the query at support@digitotech.com, or you can talk with the case owner with whom you are in contact with. We will just generate the advanced level IoT solutions which you want. So smart infrastructure, smart building, smart transportation, like what exact functionalities are you are looking for? Like if you want to have some data collected means you can go for edge devices. Okay, so where you can integrate the sensors to collect the data, and later you can build the models. Okay, and later you can go for deployment. And when you are going to monitor the data in the real time, you can go for IoT integration in that. So, if you have any specific suggestions or specific support required for your project building, you can share it in detail at support@digitotech.com. So, what other edge AI device currently available? How each of them are different? Like for edge AI, there is also Jetson Nano device. So, how it can be different from STH AI? So, my technical team they are answering for these questions. Just have patience. So virtual lab access is perpetual license or yearly renewal. So it is not like a license, but when the colleges purchasing our hardware tools, we will be providing them an 1 year access. Okay, so they will just you can just share the mail IDs through which you have registered. So we will be giving the access for those mail IDs. And if you want to go for renewal, you just need to pay for the course, and you can just go through those labs. So yeah, like using the Nano GI Studio, you can go for the Arduino or like Arduino deployment, but it supports limited Arduino versions. So you can just check in Nano GI software whether that specific part number is available. If it is available, you can just go for the deployment. I think I'm audible now, right? Am I audible now? Okay. So is there any other questions which has not been answered?
So before we wrap up, I would really appreciate if it take a minute and fill a form. Help us to get a feedback from your end, so that we can improve our next upcoming webinar. So I request attendees to fill the form that is there in a Q&A box.
Okay, so can we use Nano AGI in image processing? Actually, no, because it is used for sensor-based model building part. Okay. Yes, guys, if you have any more queries, you can just drop the question.
Okay, that's bring us to the end of today's session. A big thank you to the speaker Govardhini for sharing such a valuable insights and all on and joining us today actively. So, if you have any further questions or feedback, feel free to reach out to us. Please contact us sales at digitotech.com. So it will be it will be helping you as well, like any doubts, any questions, anything you have regarding this session or any of the our products. So we'll be there for you. Thank you all for joining in.